I'm going to go through this fast, but hopefully not too fast. Okay. I want to show you basically, when it comes to properties of logs, there's 4 properties. Okay. So when I say properties, okay, you can think of like when you talk about distribution, when you're talking about functions or equations, that's a property. Okay, I don't want to get too caught up in that. I think once I just get started directly on this, it will make sense. Okay, and most of you guys, I would say I would expect 100% of you guys to know this already. Okay, so remember, logs are very related to exponents. Okay, and when you look at exponents, let's say, for example, you have 2 to the power of 4, okay, times 3 to the, okay, 2 to the power of 4 times 2 to the power of 3, okay. When it's multiplied, what do? You add the exponents, okay, all right. And conversely, when you divide, okay, you subtract the exponents. Okay, so long story short, when you multiply when it comes to exponents, you really add. And when you divide when it comes to exponents, you really subtract. Okay, and that's the same idea. That's the same idea with logs. Okay, it's the same idea. So let me go ahead and put plus here. Okay, 4 plus 3 and 12 minus 2. Okay, so here, the way I'm going to phrase it is that anywhere you see times, okay, you're going to think plus when it comes to logs. Anywhere you see divide, you're going to think of minus when it comes to logs. Okay, so let's go ahead and let's check this out. Okay, let's look at this first one here. I'll put that in yellow. Okay, so that's log base. Okay, we're gonna start it here. That's log base 10 of 10,000. Okay. All right. And let me actually just, yeah, who cares? I'll just, plus log base 10. Okay. So this is the yellow. They match. The green, they match. Okay. And the pinks, they match. Okay. Now, 10 to the power of what is 10,000? The answer is 4. 10 to the power of what is 10? The answer is 1. 10 to the power of what is 1,000? Is 3. Okay. And does 4 indeed equal to 1 plus 3? The answer is yes. So you can see that you can not only trust, that you can not only just have faith that what I said is correct and that anywhere you see times it's plus, when you actually solve it out, you can see that your final answer still rings true when we apply the notion that anywhere you see times you think plus. Okay. Now let's go ahead and do the same thing here. Okay. Let's do the same thing here. Log base 10 of 100 equals to log base 10 of 1,000 minus log base 10 of 10. Let's go ahead and see. Okay. Boom, green, yellow, yellow, pink, and pink. Okay. This becomes 2 Okay, because 10 to the power 2 is 100. This becomes 3. This becomes 1. And indeed, 2 equals to 3 minus 1. Okay? Again, so you don't have to only have faith that anywhere you don't have to only have faith in what I say, that anywhere you see divide you think minus. When you work it out, you'll see that it's true. Okay? Now, let's go ahead and do two things at once, and let's go ahead and talk about this property also here. Okay, the power property. The power property is very easy to memorize, and it's also easy to understand. All it's saying is that if you see an exponent right here, you can move it to the front. Okay, and you get the 2 right there. All right, and let's go ahead and see if it's true. Watch this. All right, and by the way, if this were 3, that would be a 3. If that's a 4, that would be a 4. Okay, now let's go ahead and see if this is true. Okay, I'm going to do log base 10 of 1,000 times 1,000, which is 1,000,000. I'm just going to put a 1m for a million. Okay, and this is going to be 2, okay, times 10 to the power of what is 1,000? The answer is 3. Okay, I hope you guys understand how I got that parentheses of 3. All right, so here I got the greens to line up, and here I got the yellows to line up. Okay, now 10 to the power of what is 1,000,000? The answer is 6. Okay, and is 6 indeed 2 times 3? Yes. Okay, the answer is yes. Okay, all right. Let's see how a problem works out here. I'm going to give you an example of a problem. Okay, let's go ahead and do something like this right here. Okay, B. Let's do B. Now I'm going to modify B a little bit. And let's see. Should I modify B? Let's see if I have a better example here. See if I have a better example anywhere over here. Yeah, I know exactly how to modify B. Okay, so now let's pretend we have, I'm going to put a 2 right here. Okay, I'm just going to put a 2. Okay, so now let's apply these two properties we just learned. Okay, first of all, let's start, look at this 2 right here. I'm going to move it right there. Okay, so that now the problem looks like this. Okay, after moving it, this is going to look like, the new problem is going to look like this, minus log base B 3y squared. So now the new problem looks like this green highlight right here. Boom, boom, boom. That's a new problem, and we can just ignore this. Okay. Now, check this out. Anywhere you see minus, you think division. So I'm going to just start writing it like this. Log base B of 4, okay, x. And the directions here is to condense the log. Condense the log. Okay, condense the log. All right, and I'm going to move this quick because we're almost done with class. And then anywhere you see minus, you think division, and you get 3y squared. And anywhere you see plus, you think multiplication. Okay, and that's going to equal to log base B of 4x over 9y squared times y. And lastly, we get log base B. If you have one y on top, two y's on bottom, you're left with only one y on bottom. And that's your final answer. Okay, so condense the log means if there's 3 logs here, so make it into 1 log. That's what condense means, and we successfully did that. We combined 3 logs into 1 log in your final answer right here. Okay, folks, look on the PDF in a little bit. I'm gonna put like just a couple problems, not too many, so that you guys can practice this. It's like gonna be 3 or 4 problems I plan on. Okay, and that wraps it up for today's class. Okay, you can rewatch the video if you need to.